In this section, we're going to look at finding limits numerically. So we need to sort of get familiar with the TI-89 calculator that you hopefully picked up from school by now. So this calculator is going to work a little bit different. At first, you're not going to like it because whenever you do things like, let me clear this out. Whenever you do things like 9 divided by 5, it gives you 9 divided by 5, which is a little bit irritating. The way that you can get a decimal approximation for this is you can either hit the green button before you hit enter, and it'll give you the decimal approximation, or in this case, equivalency. And the other way that you can do that is if a number that you're multiplying, dividing, adding, subtracting has a decimal point in it, it will give you a decimal as your answer. So 9 divided by 5 with a decimal point behind it, there it'll also give you the decimal. So the same thing's going to happen if you try to take a square root. So if you take the square root of something that is not a perfect square, so like square root of 24, then you're going to get 2 square root of 6. Sometimes this can be really helpful because it's simplifying that radical for you, but sometimes you just need the decimal. So if you hit the green button and enter, then you'll get that decimal approximation there. Also notice right here on the TI-89, if you do not close your parentheses, it is not going to let you type that in. On the TI-84, it doesn't mind if you leave off that last parentheses, but for these, every parentheses that's opened has to be closed. So it'll look like this here. So that's just a few things about the TI-89. At first, this stuff will really get on your nerves, but it can really be helpful to you later on because you can get, it simplifies things for you that otherwise you wouldn't be able to simplify or you'd have to do by hand. So to get to the table on your calculator, you're going to press the green button and then F5. So green button, F5. You can see in green right here above it, it says table. And that will get you to the table. However, first thing that we need to, I guess it's probably the first thing that I should have shown you, is where your y equals is. It's similar to the 84, but you have to hit the green button and F1 to get to y equals. So you can see I have this sort of complicated function in my y equals right now. So we'll probably change that here in a moment. Another thing that can be helpful for these, if we go back to table, if I press F2, which is setup, the thing about the TI-89 is these tabs can change depending on which section you're in. So if you go to F2, which is setup, and go down here to the line that says independent, that's your independent variable. If you change that to ask, so go down here to number 2, hit enter, and then on the TI-89, you have to hit enter to save. So now what's going to happen, right now it's just showing automatically the numbers showing up, but because I've changed it to ask, if I want to press 2.3, then it'll give me the value for 2.3, and I could go down here and do 2.4, and then I could do 3.9, and I can just type in whichever values I want. This makes it a little bit easier to find limits numerically. So let's try our first example here. So we are going to use the table on our calculator to estimate the limit as x approaches 2 from the right of 2 natural log of x minus 2. So the first thing we want to do is go to y equals. I'm going to clear out this crazy function that I have here, and I'm just going to type in 2 natural log. Let's see, natural log. It's always a little blurry on the screen. I think it's right here, second x. Yep, 2 natural log of x minus 2. We're going to type in that equation. And what I'm looking for is the limit as x approaches 2 from the right. So I need to go to the table. So green button, F5, that takes us to the table. And I've already got it set on ask. And I want to see what happens as we approach 2 from the right. So those are numbers larger than 2. So for example, 3 is a number larger than 2. And I get 0 when I plug in 3. I guess the first thing I could have done is plugged in 2. But it gives me negative infinity, so that may not be good there. So 3, a number a little bit closer to 3, to 2 would maybe be 2.5. And then maybe I could get to 2.1. And then 2.01. And then 2.001. And 2.0001. And you can see these numbers are getting more and more negative. 2.00001. And we could keep on, put lots of zeros. You can see we're getting negative 46. Now, this one actually did, when I typed in 2, gave me negative infinity. So this is approaching negative infinity. Usually this won't happen. Usually it won't give you the answer. So this limit right here, we would say that that equals negative infinity. Now, something that we must remember with numerical limits is this is not proof that that limit approaches infinity. It just gives us a good estimate of what the limit possibly approaches, because we're going to have to use other methods to show that this happens for sure. Okay, here's our next one. We got the limit as x approaches infinity of x plus 3 over x squared minus 5x minus 24. So I'm going to go to y equals. I'm going to clear out what I had here, and I'm going to type in x plus 3 divided by x squared. There is no square button on this calculator, so you just have to do x to the second minus 5x minus 24. Close your parentheses. Here's what I really love about the TI. There's one thing I hate about the TI-84. I'm 89. I have forgotten a parentheses. Why is it doing that? I don't know why it's not inserting. Well, I've typed it back in. Sorry, guys. Okay. Okay, this is what I really love about TI-89. When you type the equation in, it looks like the math that you see in the problem. It doesn't just look like that string of letters and numbers. For example, if you type this in incorrectly, if you do x plus 3 divided by x squared minus 5x minus 24, if you don't put the parentheses in, when you hit enter, you can see that, actually I typed that in wrong anyway, didn't I? I'll go back here and change this to a division right here. But whenever I hit enter, see how I can tell this is not correct. So it really helps you keep from making mistakes and typing those in. So I've got this typed in. I'm going to go to the table. I'm looking as x approaches infinity. So I could start off with 0. And maybe 1. And 2. But it's going to take me a while to see what's happening like this. So let's skip up to 10. And then maybe 100. And then maybe 1,000. And then even larger. You can see these numbers get smaller and smaller and smaller and smaller. And it appears that this function is approaching 0 as this happens. So we would make the educated guess that this limit equals 0 based on our table. Okay, let's look at a couple other types of problems that you're going to see. Problem, it says, which of the following statements is supported by the table below? So we're looking here, limit as x approaches 2, limit as x approaches 2, limit as x approaches negative 4, and limit as x approaches 2. On this table, right here is our 2 for our x's. Notice we're nowhere near negative 4 for our x values, so C, I'm going to go ahead and throw out. So the first statement says that the limit as x approaches 2 of f of x equals negative 4. And from the left-hand side, the numbers below 2, this appears to be true. Those numbers are getting closer to -4. However, from the right side, it appears that we're not approaching -4, but rather +4. So this is a double-sided limit because we do not have a plus or a minus behind the 2 here. So we're going to throw A out. For B, it says the limit as x approaches 2 from the right of f of x is -4. From the right-hand side, from these numbers, we're getting closer to +4, not -4. So B is out, leaving us with D, which is the limit as x approaches 2 from the right of f of x, that equals 4. This is supported by our data here. So that would be our answer. Oh, I see. And so right here, all of these, most of these are approaching 0. So 0 falls right here between that -0.001 and the 0.001. And we are asked to tell which one must be false. So the limit as x approaches 0 of f of x does not exist. The limit as x approaches -5.5 of f of x equals 0. The limit as x approaches 0 of f of x equals -5.5. And the limit as x approaches 0 from the right equals the limit as x approaches 0 from the left of f of x. And then none of the above. So for this, we must consider this word right here, must be false. So if we're looking right here, we can see from the table, it appears from the table that the limit as x approaches 0 of f of x, it really looks like this value right here is probably 5.5. Now, it might not be. It might be something different. It could be 5.51. It could be 5.7. We really don't know exactly what happens. It could be negative infinity for all we really know. But it appears that it probably is negative 5.5. Now, notice, this is B. This is what it looks like probably happens in this graph. So this is not going to be our answer because this is supported by the table. So that is not the answer. It is probably correct. So we're going to throw that one out because remember, we're looking for which one is false, not which one is true. So B appears to be true from the data that we have. Now, we must decide now whether the others must be false. So it looks like that the limit as x approaches 0 of f of x approaches -5.5 or somewhere around that for this problem. However, it does say that the limit as x approaches 0 of f of x does not exist. Now, we don't really know what happens as we get closer and closer and closer to 0. Probably this approaches -5.5. But we don't know that for sure because we don't have the values closer to 0. So it is possible that this maybe approaches negative infinity. So it is possible that this limit does not exist, because if the limit did approach negative infinity, that is a limit we say that does not exist. So this is actually possible. For C, we have the limit as x approaches -5.5 of f of x equals 0. Now, this is sort of a strange thing to ask. The limit as x approaches -5.5. Well, that's way over here that we can't see because our x values are nowhere near -5.5. So this is not a conclusion that you can make according to this table, but we don't necessarily know that it's false because it's very possible that the value of f of x whenever x equals -5.5 is 0. So it is possible that this is true. It's not a conclusion we can draw from this table, but that's not what the question asked. So it is possible that C is true. Okay, D also appears to be true because it looks like the limit as x approaches 0 from the right is going to equal the limit as x approaches 0 from the left. You can see the symmetry of the numbers that you have right here. This table supports the idea that the limit from the left and the limit from the right are the same. So it supports that idea. So this also could and probably is true based on the table that we have here. So this is sort of a little bit of a trick question because none of the above must be false. There's a possibility that any of them are true, although it's most likely that B and D are true, where A and C are not supported. But remember, whenever I first began talking about numerical limits are not absolutes, they're estimates. So there's things that could be happening in between these numbers that we don't see. So there's a lot of room for possibility with numerical limits. Okay, you will have an assignment that goes with this to complete today also.